When multiplying radicals, keep in mind that the process is going to be similar as to how we multiply polynomials. When multiplying two monomials, we multiply the coefficients, 2 times 3 is 6, and then we multiply the powers. These do not need to be like terms. When we're multiplying powers with the same base, we keep the base the same, which is x, and we're going to add those exponents together. So remember, we have an exponent of 1 here. 2 plus 1 gives us the x cubed. Let's try some radical examples here. So again, there is a process. Let's go ahead and multiply the coefficients. So this has a coefficient of 1 times 1, which is just 1. Then we're going to multiply the radicands. 5 times 2 is 10. So we have just 1, which we don't need to write down, times the square root of 10. And then if possible, simplify. So check, are there any perfect squares within that radicand? There are not. So this is fully simplified. So let's take a look at the next one now. So again, we have multiplied the coefficients. Negative 4 times 1 is just negative 4. Multiply the radicands, 2 times 6 is 12, and then simplify if possible. So if I take a look at this 12, there is a perfect square that we can pull out of there, so we can take out a 4, and then the square root of 4 is 2, so I can go ahead and put that up top, and then we're going to multiply. Negative 4 times 2 is negative 8, and then we still have that 3, which is going to stay inside of the radicand, and then you are fully simplified if you have no more perfect squares within that radicand. Now in our next example, we have variables in the radicand, and we also have square roots. These have an even index, so we have to state the restriction on those variables. So here, I know that x has to be greater than or equal to 0. I also know that y has to be greater than or equal to 0. So we're going to go ahead and state the restriction first, and then we can follow our process. So step number 1, we're going to multiply those coefficients. 4 times 3 is 12. We're then going to multiply those radicands. X times y is just xy, because we are not multiplying powers with the same base here. So we're just going to leave it like that. And then because this is an index of 2, I don't have 2 x's, I don't have 2 y's. I can't simplify that any further. So this is fully simplified. Also recall with polynomials, if we have one term, a monomial, times 2 terms, a binomial, we took that first term and we multiplied it by every term in the brackets. So we distributed this in. Multiply the coefficients, 2 times 3 is 6, and then multiply the variables. So if we're multiplying powers with the same base, keep the base the same, and we're going to add those exponents together. And then we're going to distribute. 2 times negative 5 is negative 10, and then we have that x squared, no variable here, so this is just x squared. So it's going to be a similar process here, where we're essentially taking this radical, and we are going to distribute it into the brackets by multiplying this one radical by each of those radicals within the bracket. So we're going to start by multiplying the coefficients. So 7 times 5 is going to give me 35, and then multiply those radicands. 3 times 5 is going to be 15. And then on the second term, we're going to take that original 7 times the square root of 3, and we're going to multiply it by that second radical. And we're going to have 7 times negative 6 is that negative 42, and then multiply the radicands. 3 times 3 is 9. Now 9 happens to be a perfect square. So if I go ahead and square root 9, then there is no radical left. That is a perfect square. So I can put that 3 on top. And then there is no perfect square I can divide out of 15 here. So I'm going to just leave that term as is. On the second term here, we're going to multiply that negative 42 by 3. So we're completely simplified here because I have no more perfect squares I can divide out of here. And these are not like terms, so I cannot combine those. Now on this next one, I see that I have square roots, and I also have variables within those radicands. So I need to state the restriction first. Because I am multiplying, and this happens to be a positive number, I'm also multiplying, and this happens to be a positive number, this w has to be positive in each of those radicals. So I'm going to say w has to be greater than or equal to 0. It can also equal 0, and it has to be a real number. We're then going to go ahead and take this first radical, and we're going to distribute it into the brackets, multiply it by all of those radicals within the brackets. So begin, multiply the coefficients. 9 times 1 is 9, and then we're going to multiply the radicands. 2w times 4w is 8w squared. When you're multiplying powers with the same base, keep the base the same, add those exponents. And remember, if you do not see the exponent on the variable, this is a 1 in both of those cases there. We're then going to take this 9 and we're going to multiply by negative 7. That gives us negative negative 63 for a coefficient, then multiply the radicands. 2w times 28 is 56w. Then we can go ahead and simplify. So I can see that I can divide 8 into 4 and 2. 4 is a perfect square, so I'm going to go ahead and do that. And then when I take the square root of 4, that is 2, so I can write that 2 on top. W squared is also a perfect square, so I can go ahead and take the square root of w, and then we can put that up top as well. So we're going to have 2w up top, and then that 2 is going to stay within that radicand. And then on my next one here, the square root of 56, I can pull out a 4. So again, when I square root 4, that is a perfect square. I can go ahead and write the square root of 4 is 2, put that up top. And then in this case, we're going to have the square root of 14. There is no more perfect square in 14, so that one is fully simplified. And I also have a variable here that will stay in the radicand as well. 2w times 9 is 18w, and we have the square root of 2 in the radicand. 2 times negative 63 is negative 126, and we still have that 14w in the radicand. And then just take a look to make sure you do not have any more perfect squares in here, and we don't, so those are fully simplified. We also do not have like radicals, so we cannot combine those together, so our final simplified answer has the 2 terms in it. And back to polynomials for a moment. Recall that if we're multiplying 2 terms by 2 terms, a binomial times a binomial, we can FOIL this out. It's an acronym just to help us remember that every term is going to be multiplied by every other term. So we're going to begin by multiplying the first terms. So the first term in each bracket, multiply the coefficients, and then we're going to multiply those variables. So 5 times 4 is 20. X times x, when we're multiplying powers with the same base, we're going to add the exponents. So that gives us x squared. The O stands for outside. So if you think about a little house, this is your outside wall and this is your outside wall. We're going to multiply those together. So 5x times negative 7. 5 times negative 7 is negative 35, and then we have that x. The I stands for inside, so again, think about a little house here. These are your inside walls. We're going to multiply those terms together and get 12x. And then the L stands for last, so we're going to multiply the last term in each bracket together. 3 times negative 7 is going to give us negative 21. And then you can go ahead and combine any like terms. So in this case, we have a negative 35x plus a 12x. Combine those together and we get that negative 23x for that x term. There is no like term to go with the x squared. There is no like term to go with the constant term. So when we have 2 terms times 2 terms, we FOIL them out to make sure that every term gets multiplied by every other term. Let's go ahead and try this out with some radicals here. So I can see that I have 2 radicals times 2 radicals. So we're going to FOIL. I'm going to multiply the coefficients on the first term. So 1 times 1 is that 1, and then multiply the radicands. 5 times 2 is that 10. I'm then going to multiply the outside terms. So again, 1 times 1 for the coefficients is just 1. Multiply the radicands. So 5 times 7 is that 35. Then we're going to go ahead and multiply the inside terms. 1 times 1 again is just 1. 3 times 2 is 6. And then multiply the last terms. So 1 times 1 is 1. They all have a coefficient of 1. 3 times 7 is 21. Now, if you take a look at this, there are no perfect squares that can be divided out of any of those 4 terms. And we also have no like radicands. So I can't combine them together. That is fully simplified. And then with this last one here, I would pause the video and see if you can do this on your own and then resume the video. All right, so we can see that we have 2 terms times 2 terms. We're going to FOIL. So we're going to begin by multiplying our first terms together. Multiply the coefficients. 2 times 1 is 2. Multiply the radicands. 3 times 6 is 18. Then we're going to multiply the outside terms. So 2 times negative 2 is that negative 4. Multiply the radicands. 3 times 10 is that 30. Then we're going to multiply the inside terms. Negative 3 times 1 is just negative 3. And then 5 times 6 is 30. Multiply the last terms. Now be careful on the sign here. You have a negative 3 times a negative 2, that is a positive 6, and then 5 times 10 is 50. All right, so once we've FOILed that out, now we're back to adding and subtracting radicals. We need like radicals. We can also simplify these. A radicand of 18 will break into 9 and 2. 9 is a perfect square, so the square root of 9 is 3. Go ahead and stick that on top, and then we have a 2 left in the radicand. I can also pull a 25 out of that 50. So we're going to go ahead and do that. The square root of 25 is 5, so we can put that on top there. And then multiply 3 times 2 is 6. And we still have that square root of 2 in the radicand. And then on the other side here, we're also going to have that square root of 2 in the radicand. Now, at the same time, just to save time, I'm also going to combine. I can see that I have like radicals here. So I'm going to go ahead and subtract those coefficients, keeping that radicand the same. So let's go ahead and do that. And then take a look again. So make sure that you have no radicands that can be simplified. So in this case, we can't. However, we do have like radicands. So we need to keep going here. I'm going to combine the 6 times the square root of 2 and the 30 times the square root of 2 because the square root of 2, those are like radicands. 6 plus 30, add the coefficients is 36. Remember, the radicand stays the same if we're adding or subtracting. These are not like radicals, so those cannot be combined. So this is our simplified value. And then just as an aside here, so this is 1 term times 2 terms. So we're going to distribute this in. Because I don't have a radical, this is just 4. You can think of it as 4 times the square root of 1 if you wanted to. It would have the same value. Here I'm just going to multiply coefficient by coefficient. So 4 times 1 gives me that 4, and then we just have the square root of 3, and then 4 times 2 is that 8, and we have the square root of 10. And the final thing we're going to look at in this lesson is conjugate radicals. So if you think back to grade 10 when we looked at conjugate binomials, we know conjugates are where we have the same first term, the same last term, but the sign is the opposite in each bracket. So if this is a plus, this is a minus. If we FOIL these out, because we have 2 terms times 2 terms, I'm going to do this the long way so you can see what happens here. So I'm going to multiply the coefficients. 1 times 1 is 1. 7 times 7 is 49. Always, we're going to be multiplying the same radicand by itself. That's going to always give us a perfect square. So same thing here. Same thing by itself, we're always going to get a perfect square. If I multiply the outside term, I'm going to have 1 times negative 1 is that negative 1. 7 times 3 is 21. Now the inside is going to be positive 1 times 1, which is a positive 1. And again, 3 times 7 is 21. Because those radicands are the same product on the outside and the inside, when I have negative 1 plus 1, those are going to zero out. I go to then multiply the last terms, and again, we have a positive 1 times a negative 1 is that negative 1. 3 times 3 is 9. Always, this is the same thing times itself, same thing times itself over on that other example. That's going to give us a perfect square. So now, if I go to square root 49, we're going to end up with 7. That's a whole number. If I square root 9, we're going to end up with 3. That's a whole number. So now 7 minus 3 is 4. I'm always going to have a rational number as opposed to an irrational number with radicals in it when we have conjugates. So let's take a look at this next one here. We're going to multiply the first terms, the outside terms, the inside terms, the last terms. Always, I can see that these 2 terms, these are my like radicals. Negative 12 plus 12 is 0. So those are always going to be zeroing out. I'm always going to get a perfect square on that first term. So the square root of 4 is 2. The square root of 25 is 5. So actually, maybe let's go ahead and put those up there. Then I can multiply. 6 times 2 is 32. And then on that last term, negative 9 times 5 is that negative 45. Subtract those, and we end up with negative 13. So always, if we have conjugate radicals, we're going to get a rational solution.